Hi everyone, welcome to my YouTube channel. This is Vivek and this video is going to be the first video in my content creation journey on YouTube. So first of all, let me set the context for this video. This video is all about how we can learn system design in structured and simplified way, and I was super excited to make a video on this topic. Now imagine this, what if that small project you built, your little application, suddenly went viral and hit millions of users overnight? What happens then? Obviously servers will crash, database freezes, notifications fail and whatnot, and users they get frustrated. So this is the moment where you realize coding is not enough and you need system design. So today in this video I'm going to walk you through a step-by-step system design roadmap, the exact path to learning system design that will not only help you to crack system design interviews but also enables you to build real systems that can scale and handle millions of users. So without further ado, let's get into the video. Writing code makes features, designing systems makes companies. And system design is all about building experiences that can scale, survive, and stay reliable under pressure. Now think about it, WhatsApp processes billions of messages daily without any lag. And Netflix streams personalized content to millions in real time. And Amazon handles millions of transactions every hour without downtime. That's not a magic, that's an architecture. And that's why interviews focus on it so much. Companies don't just want coders, they want engineers who can think at a scale, anticipate problems, and design solutions that last. System design is divided into two parts, high-level design and low-level design. First, high-level design, or you can call it as HLD. Think of it like a blueprint of a house. You just have to decide how many rooms, where is the kitchen, where is the hall, and how they connect. In tech terms, HLD is about the big picture, like the main components and how they will talk to each other. For example, if we are designing an Instagram, HLD would include things like the mobile app, backend servers, databases, CDN, cache, load balancer, etc. and how all these connect. Next comes low-level design, or you can call it as LLD. This is like a planning what's inside each room, like where is the fridge, where is the TV, and so on. In tech terms, it's about the details like database schemas, APIs, algorithms, and edge cases. For example, Instagram's LLD would include things like user table, the API for uploading a photo, the data model for a comment, and how feed algorithm works. So simply put, HLD is a big picture or a blueprint, and LLD is all about the details and internal working. Both are important. HLD makes your system scalable, and LLD makes it work correctly. Now that you know HLD and LLD, let's break down the system design roadmap step by step. First, we will start with high-level design. Before tools and frameworks, you need to master core fundamentals, like what is system design and why it matters, functional versus non-functional requirements, vertical scaling versus horizontal scaling. Vertical scaling is like upgrading one bigger server, and horizontal scaling is like adding many smaller servers. Then we have threads and pages, consistency, availability and reliability, latency, throughput and fault tolerance. And it is also important to understand performance trade-offs. For example, e-commerce platforms lean towards consistency. We don't want our order to be placed twice right. While social media apps can survive with eventual consistency, like a story or comment may appear a few seconds late. Understanding these trade-offs is the real starting point. Next is databases and storage techniques. Your databases and storage techniques are the heart of your system. Relational databases are great for transactions and structured data. NoSQL databases of type document, key value, columnar, graph are great for flexibility and scaling. Then we have in-memory storages like Redis and Memcached. And it is also important to understand indexing and query optimization. Then you will hear terms like sharding, replication, and partitioning. In communication and networking, we have APIs like REST, which is simple. WebSockets keeps things in real time. gRPC is fast. Every type has a different use case. And if you have ever wondered how Zoom or Google Meet works, that's a WebRTC and video streaming. Then we have basic topics like TCP, UDP, HTTPS, DNS, proxy, and reverse proxy. Next is caching and content delivery. Caching is the secret ingredient for speed. Here we have concepts like basics of caching, cache invalidation, write policies like through, back, around, eviction strategies like LRU, LFU, FIFO, etc. Then we have to look at distributed caching systems. And then we have CDNs, and they make sure images, videos, or files are delivered quickly to users worldwide. For example, without caching, Instagram or YouTube or any other application will work very slow. There is one important topic called load balancing and traffic management. When many users hit your application at the same time, you don't want all of them to overload a single server, right? Load balancers distribute the traffic efficiently using strategies like round robin, list connections, or geo-based routing. This is how large-scale applications like Netflix handles millions of requests smoothly. Here we have load balancing algorithms like round robin, list connections, and weighted. And we have few concepts like stateless and stateful load balancing, consistent hashing, rate limiting and throttling, anycast, and geo-based routing. Next, we have some of the distributed systems concepts. This is where things get fun. Here we have cap theorem consistency models. They tell we can't have everything at the same time, like consistency, availability, and partition tolerance. Here we have some of the concepts like eventual consistency, quorum-based systems, message queues, and event-driven systems like Kafka, RabbitMQ, and SQS. They helps to handle millions of events reliably. And we have PubSub models, they power real-time notifications. If we talk about the architectural styles, here systems can be built in different ways. Every style has pros and cons. The key is to know what fits best to your system. Here we have monolithic applications, concept of single point of failure, microservices and service discovery, event-driven architectures, serverless versus traditional serverless models, containerization using Docker, and orchestration using Kubernetes, and how to migrate to microservices. Next comes observability and security. Observability means you can see what's happening in your system, like logs, metrics, traces, or anomaly detection, etc. Security means keeping the user's data safe, using encryption techniques like OAuth, JWT, etc. Observability and security both are crucial because you want your system to be reliable and safe. And also we have to look at how our data is encrypted when data is in transit and data is at rest. Threat modeling and basic security measures. If we talk about the system design trade-offs, there is one golden rule in system design, and the rule is everything is a trade-off. There is no perfect system, there is only the right system for your problem. Here we have trade-offs like consistency versus availability, latency versus throughput, performance versus cost, SQL and NoSQL DBs, scalability versus simplicity, durability versus availability, and push-pull architectures. These trade-offs are some of the most frequently asked interview questions. Theory is good, but practice is where real learning happens. You can practice HLD by trying problems like messaging apps, social media feed, video streaming platform, ride-sharing systems, and file storage systems. Each one teaches you a new principle. This is all about high-level design. Alright, HLD makes sure your system scales, but LLD makes sure your system works correctly. And here is what to focus on. If you talk about core programming, and oops, good code is the foundation. Abstraction, inheritance, encapsulation, and solid principles make your code maintainable and extensible. Next comes design patterns. Patterns are proven solutions to common problems. Here we have creational, structural, and behavioral patterns. Knowing these patterns helps you write clean and more organized code. In concurrency and multi-threading, real systems handle multiple users at the same time. Understanding threads, locks, race conditions, and async programming is very important to avoid problems like deadlocks. And we also have to look at producer-consumer problem, thread pools, executors, etc. Next is UML diagrams and modelings. Diagrams helps you explain your design clearly. If you check the system design interview experiences, then class diagrams, sequence diagrams, and component diagrams are very common in interviews. In API designing, APIs should be simple, versioned, and backward compatible. Clear APIs makes life easier for other developers. Here we have to study some of the principles like RESTful API design, request response modeling, API versioning and backward compatibility, error handling and validation, avoiding anti-patterns like God classes, tight coupling, etc. And we also have to follow some of the clean code practices as mentioned here. Sometimes it is also important to test the code that we have written, right? Using unit testing, integration testing, etc. And it is always better to follow the test-driven development. Next we have machine coding. This is interview-oriented topic, and if you check the interview experiences, this round focuses on building only functional features in 1 to 2 hours. Here you need to write clean, modular, and extensible code, handle all edge cases, and model a real-world problem using OOPS concepts. You have to use the right data structures, design patterns, and you have to ensure your code is easy to test and maintain. Here common examples include parking system, ride sharing systems, and food delivery systems, etc. And this is the list of machine coding problems that you can practice. And this is all about low level design. So that's the complete system design roadmap. HLD gives you the big picture or a blueprint, and LLD gives you the details and internal working. Thanks for watching this video till the end. Do check out the description. I have shared some useful resources to help you go deeper into the system design. If you find this video helpful, like the video, drop a comment, and share it with your friends. And don't forget to subscribe for more such tech content. So on that note, this is Vivek. See you in the next video.